Today that maybe sounds familiar, maybe doesn't, and it's this word right here, slope. Everybody say slope for me. Have you guys learned about slope in math before? Some of us have, some of us haven't. Where have we heard the term slope before? Maybe not in the math class. In a game. What does the slope game look like?
A ball, and it's going downhill.
What'd you say, Alicia?
It's a ball that goes downhill.
It's a ball that goes downhill, right? This is that like lime green game, right? With all the lines and stuff? Okay, yes. So that's typically where 8th graders hear of slope for the first time, is that game. And the way that Alicia described it is perfect. It's a ball rolling down, what is it, like a hill or something?
Yes.
You got obstacles, right? So in the most very basic terms of the game, right, it's a hill and there's a ball, right? Now it's called slope because all the hills that you roll down have a certain degree of slope. Slope is just how steep something is, right? Anyone ever been hiking before?
Yes.
Some of us? Anyone ever been skiing or snowboarding before? Okay, if you've been skiing or snowboarding, they say you hit the slopes, right? It's the same thing here. You're up here with your little, I don't know, is that what skis look like? I've never been. Right, you got your little goggles, okay? Knowing you guys, you'd have your little ski masks on. Okay. So this is you skiing. You're skiing down the slope, right? So the slope of the hill is how steep it is. If I just start out skiing, I've never been before, should I go on a mountain that's this steep, you think? No, I should probably start on something that looks a little bit more like this, right? Right? It's kind of hard to tell the difference, but you want to start with a lower slope, something that's a little bit more flat, just to get used to it before you start going down these crazy super steep slopes, okay? So slope is just a measure of how steep something is, okay? Does that kind of make sense? No? Do you want me to explain it all again?
No.
Good. I appreciate your honesty. So slope, in terms of a math sense, is just the ratio between the change in y value, which as we should know by now is pink, and the change in x value, which as we should know by now is yellow, from one point to another on a line. Now, slope is essentially the same thing as k. So, last week, we spent the whole week learning about k. We'll put the y over the x, like the phrase, why aren't you over your x? We put those numbers in a fraction, we simplify it, and that's how we would find k. We're going to find slope the exact same way. It's going to be a little bit different, but the core idea is the same. All right? Like I said, it's the measure of how steep a line is. If it's a super, super steep mountain, I'm going to have a higher slope. If it's a kind of flat mountain, like a walking path, that's going to be a really low slope. All right? But like we said, it's just a fraction. My numerator is the change in y, and my denominator is the change in x. So we measure this change in a couple different ways. On our table, we do our arrows. Figure out what I'm changing from point to point. With our graph, we kind of draw our lines. We look down, we look over. That tells me my change. And just to make our lives a little bit easier, specifically my life, instead of saying the change in x, we're going to use this little symbol here. What does this little symbol look like?
Triangle.
A triangle. This is called a delta symbol. Everybody say delta. Like the airlines. And that delta just means change. All right, so if you see triangle y, that just means the change in y. And if you see a triangle x, that just means the change in x. Right? Give me one second. So another way we could say it besides change in y, change over x is rise over run. Does that phrase sound familiar to anyone or no?
No.
Good. Everybody say rise, over, run. Rise over run.
Rise over run.
Okay. So if I'm rising, what direction am I going? I'm going up. If I'm rising, I'm going up. If I'm running, right? If I just started taking off running right now, what direction would I be moving?
Forward.
Forward, yeah. We could think of it like forward, or we could think of it like left and right, right? I'm not going to just start running straight up into the air or running straight down into the ground. Running is going left and right. Rising is going up or it's going down, okay?
Wait,
So-
how do you rise down?
How do you rise down? Ever been to a funeral?
Why do you have to say it like that?
That's how, you want to know. You rise down if you're going into the ground. I can only think of one time I would be going into the ground.
I mean, once you bite the curve.
Right. So rise going up and down, run going left and right. On a graph, we're going to need to know the difference between those two. So when I draw a slope triangle, it's basically just a visual representation, and we're not going to get into it. We'll see what that looks like in a second. I don't want to overcomplicate it with words because the process of what we're doing is actually really simple. All right. So I've got a line here. Everybody see this line on the graph? Yeah? What do we notice about this line that's different than the lines we've been seeing so far? It has a line going from the top to bottom. Sure, Vanessa, what were you going to say?
It has negative.
That's right. There's negative values all the way down here in this corner. Right? What did think back to last week, all of our graphs went through a certain point. Do you guys remember what that point was?
The origin.
The origin. Does this line go through the origin?
No.
No, my origin's right here. So I completely miss my origin. So because of that, I know this line here is non-proportional. If you remember, proportional relationships are straight lines that go through the origin. This may be a straight line, but it doesn't go through the origin, so it's not proportional. Right? So we're not going to find K, we're going to find the slope, which goes by the letter M. I don't know why it doesn't go by S, but slope for some reason is M. Probably has something to do with Latin or Greek or something like that. So, very easy steps. Again, I always, when we're doing something like this, love to break the notes into steps so that if you wake up on the day of the test forgetting everything, you can go to your notes and just literally follow these steps to be able to do what we're about to do. We're going to start at the leftmost point. So I got 2 points here, right? I'm going to start at my leftmost point, which is right here. All right, everybody put your finger on that left point. Don't write anything yet. I just want you to follow along with what I'm doing. Johnny, put that away. Thank you. So I'm going to start at this point, and I'm going to get to this point, right? My starting point, my ending point. My fraction over here is rise over run. So the first thing I want to do is rise. Starting at this point, if I want to end up at this point, does it look like I'm going to be rising up or down? I'm going to be rising up. So the first thing we're going to do is count the rise. The number of spaces up or down. 1, 2, 3. Why did I only go 3 spaces up? Why didn't I go 4 spaces up? Phaedra? That's right. My second dot is right here. I only want to go as far up as I can until I'm in line with that second dot. So I rose 1, 2, 3 spaces. Go ahead and draw a little 3 next to that pink line. You can do it with your highlighters. 1, 2, 3 spaces up. Then I'm going to count the run. I'm going to count the number of spaces to the right. Notice how it doesn't say left or right. If I start with my leftmost point, I'm always going to be running to the right, okay? You're going to hear me say that a ton of times over the next couple weeks. Just keep that in mind. We're always running to the right. Anyone ever play like a Super Mario game before?
Yeah. I did.
Yeah? You notice how like Mario stays in one spot and he's always running to the right? You know how the world kind of moves? Once you go to the right, can you go back to the left? No, it kind of stops and goes away. So we want to think about slope like that Mario game. You're always running to the right. Well, from your perspective, the right is this way, right? Is this way the right for you?
Yeah.
For me, it's this.
Yeah,
That's literally where he.
because I'm saying from my perspective, the right is this way, right? But you're all,
Yeah.
you know what I mean? Yeah, exactly. So I went 3 spaces up, and then I'm going to run to the right. How many spaces does it look like I need to run to the right? 1, 2, 3. So 3 pink spaces up, 3 yellow spaces to the right. Now I need to set up a fraction, just like before, where I'm going to put my rise over my run. And then, of course, as with any fraction, I want to simplify it if I can. If I ignore these parts of my line, what little shape did I form by doing this process? A triangle. That is my slope triangle. All this blue space right in here. See how that forms a little triangle? That's what I want to do. So I'm going to set up a fraction. Slope, which is m, is the change in y, or my rise, divided by the change in x, or my run. All right? On our graph, when we made that slope triangle, how many spaces did we rise up again in pink? 3. How many spaces did we run over to the right in yellow? 3 again. Well, what is 3 divided by 3? 1. What are my units here? Nothing. So now we're kind of moving away from the need for units, at least in this respect. We're not talking about miles per hour or dollars per minute or anything like that. This is just a random line on a random graph. The only thing we can do is find the slope of it, or how steep a line is. Okay, this tells me my slope is 1. That means my line is not too steep, it's not too flat, it's exactly in the middle. Anything less than 1, we're going to start to get a more flat line. Anything more than 1, we're going to get like a straight up and down super steep line, like we'll see on the next page. So because our rise direction in step 2 was up, that means that our slope is going to be positive. Right? If you got your money up, is that a good thing or a bad thing?
Good thing.
That's a good thing. Right? If you're playing basketball and your team is up, is that a good thing or is that a bad thing? If your team is up, that's a good thing. So when I think up, I should think positive things, right? If I uplift you, now you're feeling good, you're feeling better. Up is a positive thing. Therefore, this line has a slope of positive 1. Now we can have a negative slope. All right, let's take a look at the second page here. Any questions on this first one? Quick show thumbs. How easy is this feeling? Thumbs up, feels easy. I know how to count, Mr. Church. This will be fine. Thumbs sideways. I'm a little iffy on my counting. Good. Joseph's up. Z's up. Michaela's up. Okay. Let's take a look at this second one. All right. What do we notice right away about this line? Anything interesting? Anything maybe we're familiar with seeing? Yeah, Vanessa? It doesn't go through the origin? Well, where's the origin? 0, 0. Does this line go through the origin? Yes, it does. So what can we call this relationship? Proportional. Now, it looks a little bit different than the proportional relationships we've seen because normally we only see this much of the graph. We only see the top right quadrant, right? But now we see the whole thing. It's still proportional. It's a straight line that goes through the origin, right? I'm going to start at my leftmost point. Where is my leftmost point here? If I got 2 points, which one's on the left? The middle. This one. This is my leftmost point. All right. Here's my starting point. There's my ending point, right? Imagine this is you at school. This is your home. Parents can't pick you up. You got to walk, all right? What direction are you going to walk first?
Right.
Remember, I got to rise before I can run. So what direction am I going to rise? I'm going to rise up. How many spaces up do I need to go? 3. 1, 2, 3. Now, a good way for us to remember which direction to go first, okay? This phrase, rise over run, is going to get burned into your brain over the course of this year. Anyone go for runs just for fun?
Yeah.
Some of us? Okay, can you go for a run if you are sleeping? If you fall asleep in PE, are you able to do the run? No. So before you can run, you have to rise, right? I have to rise in the morning. I have to wake up before I can go for a run. So when I'm doing my slope, Ayana pointed out, oh, I'm going to go to the right. Well, that's running before you even rise. We can't do that, right? I'm glad you brought that up. So I'm rising 3 spaces. Now I'm always going to run to the right. How many spaces to the right does it look like I need to go?
3.
3? Let's count them. 1, 2, 3, 4 boxes over gives me a run of 4. So to recap, I went 3 units up and I ran 4 units to the right. All I did was count, right? Everybody here knows how to count, I would hope. If not, you'll figure it out. It's pretty easy, right? And now I just have to set up a fraction with the 2 numbers I found. So what's my fraction going to look like? 4 over 3?
3 over 4.
3 over 4. Why does the 3 go on top?
Because it's when I rise.
Because it's our rise. We got to rise first, and then we'll run. 3 over 4. Can I simplify 3 over 4 at all?
Yeah, 2.
Don't let my eyebrows fool you. Can I simplify 3 over 4? No, certainly not. M is equal to 3/4. Is this bigger than 1 or smaller than 1? 3 over 4, smaller than 1, which means this line is a little bit flatter than the line we saw on the other page. This line is a little bit flatter. All right, we can tell because slope is just a measure of how steep something is. Now, because the direction of our rise once again was up, that means our slope is going to be positive here. Therefore, we've got a slope of positive 3 over 4. Did I mention last week that I hate decimals? Did I tell you guys that?
Yeah.
Okay, perfect. This is a prime example. I never ever want to turn my slope into a decimal like 0.75. Never, ever, ever, ever do that. Okay? Keep your slope as a fraction because this fraction tells me 2 directions. It tells me my rise and it tells me my run. Right? If you're here and you're like, oh, how do I get over to Raising Cane's? And I go, oh, you just go down the street. Do you think you're going to be able to find it? No. If I just say go down the street, you might go the complete opposite direction. Okay, I'm saying if you don't know how to get there and you're asking for directions, right? You wouldn't ask for directions if you knew how to get there?
You gotta go up the street, turn right.
There we go.
And then keep going straight and then go like turn left and then go straight. And like keep going straight until like you see like that big kind of mall.
Exactly. See, the more specific you are, the easier it is to find. So if I keep my slope nice and specific, that's going to help me out when we get into the more difficult stuff. All right? I don't want to take too long. Last example, example 3. Is this line going through the origin or not? No. So what type of relationship is this? Non-proportional. Does not go through the origin, but that's fine. I'm starting at the leftmost point. Which one is my leftmost point? Is it the one that's up or the one that's down? Which one's furthest on the left?
That.
This guy or this one?
That's
This one. That's right. This one is on the left. Okay, here's L for left. I'm going to start right here. Now, do I want to rise first or run first? I want to rise first. But what direction does it look like I have to rise here?
Down.
Now I've got to rise down. That's right. If I go up, I'm going further away from Raising Cane's. I got to go down if I want to make my way over there. How many spaces down did I have to go? 1, 2, 3, 4 boxes. So this time I rose down. Sorry.
Hey,
Does this sound like lies down?
I just.
Sorry. That first box is supposed to be a 4. So rise 4 units down. What direction am I going to run now, though? I'm at this point. I want to end up at that point. Where do I have to run? To the left or the right? To the right. I'm always running to the right. How many spaces to the right? 2 of them. 1, 2 boxes to the right. So if I want to find my slope, I'll set up a fraction of rise over run. How many units did I rise here? It was pink. I rose 4 units. And how many did I run? 2. Now, this is where we have to be careful. What direction did I rise again? I went down, which means my 4 is actually a negative 4. This is how we can have a negative slope. If I'm rising down, then my slope is negative. So because the direction was down, our slope is negative, right? Just fill in those blanks. Can I simplify 4 over 2?
Yeah.
Yeah, what does 4 over 2 simplify to?
-2.
Just negative 2.
Oh,
M equals negative 2. All right? Sound good? Pretty easy, right? It's just counting, setting up a fraction, making sure you set it up correctly. Again, if you follow the steps in our notes, it should be pretty straightforward, pretty easy. All right, if you get stuck or if you're unsure, I know we're used to Alex now, but we're getting a worksheet today. Let me explain this first, and then you can go to the bathroom. All right? Okay. With your worksheet, you're going to get a line. The line has 2 points, okay? I want you to use your highlighters. All right? I'm going to start with the left point. I'm going to rise, in this case, down. And then I'm going to run always to the right. How many units did I rise here?
3.
Look at the pink line. How many units?
2.
2 units. Did I go up or down?
Down.
Down. So should that be a positive 2 or a negative 2? Negative 2. How many units did I run over? 2. Everyone with me on that?
Yeah.
Okay, what's negative 2 divided by 2? That's all it is. All right, you guys can do that, right? Yeah. Elijah, question on that?
It's not a question. Something down.
Okay.
And it